Hello everyone, today we will be learning how to make a distance display system using Arduino Uno in Tinkercad. So let's get started. Before that you will need to open Chrome and search for Tinkercad and click on the Tinkercad's link. Once the Tinkercad link is open, click on the create button and click on circuits. You will get interface in this way. At the right side you will get all of the components present in Tinkercad. So let's take Arduino Uno. As we know, we are going to make a distance display system. We'll need a display that will be LCD display. So let's search for LCD. We'll be using LCD that is 16 by 2 I2C model. So it is present over here. Now let's move it over here. Okay. Now to sense the distance, we'll need a sensor. That is ultrasonic sensor. Now let's search for ultrasonic distance sensor. We'll take the second ultrasonic distance that is in dark blue color with the code as HCSR04. Now we'll require only these three components to make our distance display system. Now let's connect all those respective wires to our Arduino Uno. As we know, VCC will be used as a power, so let's connect to the power source of our Arduino, that is 5 volt power. Same we will connect VCC of our LCD screen. Okay, now let's connect ground in the same way to the common ground of our Arduino Uno. Okay, so we have connected the basic wires of our Arduino Uno. Now let's connect trigger and echo pin to the digital pin of our Arduino. So digital pins of our Arduino starts from number 0 and ends with number 13. Now let's connect trigger with the any random pin. Let's connect it to the pin number 7 and let's connect echo pin with the pin number 6. Okay, so we are done with the connection of our sensor. Now let's move to the display part. We will connect SDA with the pin number A4. We will be connecting our LCD display with the analog pin of our Arduino Uno, and let's connect SCL with the pin number A5. Okay, so we are done with the wiring work of our components with Arduino Uno. Now let's color them so that we can differentiate them. Now let's color VCC, that is power pin, with color red. Let's color ground wire with black. Let's color echo with yellow and trigger with orange. In the same way, SDA with color blue and SCL with purple. Okay, so we are done with the components part. Now let's move to the coding part of our project. Now let's click on the code button and go for blocks and click on the text icon. Okay, so we have got a basic code over here. As we know, Arduino uses C code. So let's start with it. As we are going to use LCD display, this display requires a specific library to work, and the name of library is Adafruit liquid crystal. So let's import it with the help of #include. #include Adafruit _ liquid crystal.header. So we have successfully imported our Adafruit library. Now let's move to the prerequisites of our project, that is variable duration and distance. So long duration and int distance. Also we will need to create a variable for library with the help of Adafruit. and we will name it as a LCD, that is at number 0. Now we are done with the prerequisite. Now let's move to the further part of our project, that is void setup and void loop. So before that, let me tell you that void setup is used to give the instructions to Arduino and void loop is used to give the instructions to our components. Now let's check that. As we know that pin mode is used to give the instructions to the Arduino that what pin we are going to use for what purpose. Now as you can see over here, trigger pin is used for output and echo pin is used for input. So we can see over here, trigger pin, that is of orange color, is connected to the pin number 7. So now let's rename it as a pin number 7. With the same, we will be using one input pin, that is of echo. So echo, colored with yellow color, is connected to the pin number 6. So we will rename it as a pin number 6. Okay, we will be using serial begin function. With the baud rate of 9600. Now as you can see over here, we are going to use LCD, that is of 16 by 2 size. So we will be renaming it as a LCD dot begin, that is of 16,2. In the same way, we will need some message to be displayed before the main output of our sensor. So we will be using print function to print some of the characters on our display. We will be using distance, so that after this colon it will give us the distance in centimeter as an output. So we are done with the void setup part of our coding. Now let's move to the further looping part of our project. Before that, I would like to tell you that once we start the sensor, it will be giving us a unwanted output. So once we start the sensor, we will also need to turn it off. So we'll keep it as a low once it's started. Using the digital write function, you will write to the sensor. So with the help of this, we will be using trigger function, that is used as an output at pin number 7. So we will write it as a pin number 7. Now we will keep a delay of 500 milliseconds. In the same way, once we have turned off our sensor, we will need to turn it on again with the help of high at the same number pin as a 7. Now we will keep a delay as it is over here. After that, we will also need to turn it off. So with the help of digital write at pin number 7, we will keep a signal as low so that it will get turned off. After that, there will be a main function to calculate the distance. To calculate the distance, we will be using pulse in function, so that it will give us the output, that is time taken by signal to return to echo pin, that will be at the pin number 6. So let's write a main code over here. That is, we will be storing all this output in the duration, as we have created as a prerequisite. Duration equals to pulse in at the pin number 6, that is the echo pin. You can see over here it is connected at the pin number 6 with signal as a high. Now we will need our distance in centimeters. So to calculate it in centimeters, we will need a formula. A formula to measure of speed of sound is 0.034 divided by 2. So let's convert it into the centimeters. We will need a distance variable to store this output in centimeter format. Now let's multiply our speed of sound formula with the duration. So duration into 0.034 divided by 2. Now we are done with the calculation part of our project. Now we will need to display all those output to our display. Now with the help of LCD dot set cursor, we will first set our cursor to the first column and first row with the help of 0, 1. Now we will need to print. With the help of LCD dot print, we will print our distance, that is calculated in centimeter. After that, we will need a notation to print, as we are going to print it in centimeters. So after this, it will just print, that is centimeter. After that, we will be setting a delay with 50 milliseconds so that our display will not flicker. So we are done with our coding part of our project. Now let's test our code with the components with the help of start simulation button. Okay, so here we have got the error. Okay. As you can see, our display has been turned on. Once we click on our sensor will start working. Here you can see object is kept in front of our display. If we move the obstacle far away or close to our sensor, it just changes its output. If we move our object from the distance or from the viewpoint of our sensor, it will create or give us the output as a 332 as a default output. If the object goes in the viewpoint of our sensor, it will give us a output. So yeah, we are done with our project. Thank you.